Good morning, everyone. I'm Suraj and Rocket Chat, and that's my Twitter handle. Slides and code, which I'll talk about, is here. So you might want to take a screenshot or I'll show you. So I want to talk about signals. Like, does anyone remember erasure of font?
Richard does.
I was an early user, and it turned out into a signal in the signals tournament. So, from a classic user's perspective, these terms are new. What's a signal? It's like an indication about movements in the stock market, or about any stock. And then comes the universe. So a universe is a list of tickers for which Numerai wants the signals. And it's updated in each round, and yeah, we want to predict for live tickers. So why signals in the first place? So the master plan is to monopolize intelligence, data, money, and then decentralize the monopoly. The features in the classic tournament are fixed, so you can only get a certain amount of information out of it. With signals, it allows to embed new and unfound signals into the meta model. So these are two tournaments. There are some similarities between classic. One is the scoring function, which is Pearman's correlation, and now TC. Neutralization can be applied to both tournaments as well. The targets neutralize 20-day returns. And are we getting more targets and signals as well?
Yes.
And they are in a similar form. There are data splits, training, validation, and live, and metrics as well. But how it differs is the data. For classic, we use the provided data, and for signals, we bring our own data and we generate features. And this is how the targets look like in the range of 0, 0.25, 0.5, 0.75, and 1. If I'm not wrong, 1 means we want to go long on that. 0 means we want to go short. And what type of data can we use? It's like, it could be OHLCV data, textual data, fundamental data, futures options data, or any kind of data that can be quantifiable. It could be like the candlestick or Wall Street Bets sentences to the moon, worst quarter in last 3 years, stocks only go up. You just need to convert them into a number. So with textual data, we can load data from news sources like tweets or Wall Street Bets or any kind of community which talks about finance. And then we can use a pre-trained sentiment model, or you can train your own model on that. And then you can rank them based on those sentiment scores. So here's how I experimented with Wall Street Bets data, and this is how it looks. This is the SPY and the Fourier transform of these sentiments. And you can find more about on this two node source, Carlos Owen, and here's mine. I'll be focusing more on OHLCV data, like the technical analysis and how can you map that to the targets. The idea is to get quality data and then generate a bunch of features and then turn them into classics formats. So all your strategies that work in Numerai Classic now works on signals, this data format as well. Here's how it looks like. The full data is stacked and how it looks on the group. We'll be using Yahoo data. So some of the features that we can generate are moving averages, exponential moving averages, RSI, MFI, MACD, crossovers between the different moving averages and whatnot. This is how a typical OHLCV and a technical analysis chart looks like. And here's how a bunch of features generated. So this is before the post-processing. And we need to bring them into a format where 0 means the same thing across different eras. We can do min-max scaling, Z-score maybe, but we need to be careful of peeking into the future. We don't want to rank them in the future. You just want to do it in daily time frame. We can use percentile transformation. quantile-based discretization, it kind of brings it into the classics format that we'll see. And after that, it looks like this. This is very similar to classics data, except we don't have target yet, which we'll be adding. After the merge target, this looks exactly like classics tournament. We just need to replace the date column with era, and now all your models that work in classic now works on this one. You can use any kind of model on top of that. And here's how a submission file looks like. This is the past predictions, and these are the live predictions. You can only submit the live predictions as well. And I would like to walk you through a Colab notebook. It's real.
Yeah.
These are the imports. Let's get that. Here's how we can load the live universe. So these are the tickers for which we want to make predictions for this round. And we can use open signals to load the data, which uses Yahoo finance data. And then this is the raw data, how it looks like. And then I tried adjusting and then cleaning the data because there are some negative values in it which wouldn't work. So this is the cleaning and some adjustment on the data. After that, it looks like this. And there are 5,167 tickers in the data for which we have data. Here's a bunch of technical analysis, technical indicators. This notebook is mainly built on Jason's notebook. I just added a few more features and parallelization. So we can quickly generate multiple features for multiple periods. And then after, it looks something like this, which is non-post-process data. Here's how it looks on the chart. Here's an interesting thing I noticed. If we are using all of international data, there are currency differences. So how do you come across that? So instead of using raw moving averages or exponential moving averages, you can do a crossover between them. So a crossover between a moving average of 3 days to 7 days and a 3 days to close prices. So it gives you a relative sense of like how much the price is, or the average is above the closing price or below the closing price. So this kinds of help in the currency differences. After we have like 26 features. And we can add some lagging features as well, and that brings our total to a bunch of them. After merging targets, you can see that the targets are somewhat normally distributed. Now we have 21 features, out of which we'll be using all of them. And we can use some feature filtering methods as Jo talked about, like the mean correlation to select the best one. And it looks like most features are highly correlated, 0.012. And we need to submit for live data, so we are filtering the live samples from the data as well. So now we have training data, validation data, and live data. We can simply train any model on top of that and make predictions. Here's how it looks on local testing. This is for training data. This might not be exactly same as you see on the back test on diagnostics. This is somewhat similar, closer. Here's on training data. And here's
Does that versus the Numerai target?
Yes. here's for the validation data. These are smoothened score, but you can see the number exactly. And then that's it. You can do the feature importance to see the best one, the model things. And then you can use your APIs to directly automate the Colab notebook. Or you can just download the script and upload it and profile.
Do you find that like because you're saying this looks a bit like diagnostics,
yeah.
and do you find that the pre-neutralization stuff that diagnostics is doing tends to help or hurt your versus like that?
Well, I don't know, because I just use it for local testing. So if it's better than my previous one, I use it.
Okay.
And then I check again on diagnostics, and that's the final.
And it typically looks the same.
Yeah, usually same. Sometimes different. This one is a bit different. And here's how it looks on diagnostics. The regular one and the TB200. So now the idea is to use quality data, avoid the survivorship bias and look ahead bias, somehow work around the currency differences. You can also submit raw features instead of mapping them to the given targets. You can just ensemble them and submit and rank them. You have 50 model slots, do a lot of back tests. And you can only submit live predictions as well, only for the live split. So this kind of reduces your compute overhead. See, what you can do next is look for other indicators, different modeling techniques. Create an individual or your own targets. You can look at returns for 60 days, and then you can train on them to experiment and submit more models and see which one works. Participation with Rocket Chat and Numerai. If you don't want to go through the hassle, you can just load and quickly get started. Office hours videos also help. And round 235 will start today. So you can just go to the notebook link, run it all, and get your first model running in like 1 hour, and you can submit that. Here are some resources that you can go through. And here's the link you can load, and then you can go to the Colab notebook, which has all the code which you can run. That's it. Thank you. Any questions?
Good.
So for your own models, you don't have to share all the secrets, right? Have you created your own target, like some fancy targets?
I used the notebook shared by Arbitrage and JRB, the Bootstrap target notebook. I did use them, custom targets.
Okay.
Do you try to get good IC as well?
I was thinking about that. One of my models started getting good IC, but I'm not sure what was the reason, because I haven't documented well.
Okay.
What's the unexpected feature that you use besides all the technical ones? Like, did you use any text sentiment and stuff like that?
I was submitting like 7 models based on different textual data.
Oh,
And all the tools. Someone using watch it best. There's also a notebook which you can load to watch it best data. But it was like you don't get all the signals. Currently, I'm submitting almost like 97% of live universe, but with watch it best, you just get 100 or 200 stops. It's awesome.
Are you buying any data? Is there anything you would recommend?
I'm using the HD data for like $25 a month.
It's a good one.
Yeah, the end of.
Oh, right. I bet that's a good one, yeah. So that's just still prices.
Yes, we shall see.
Is there limits though? Like how many calls you can do with it per month?
I think there is limits, like not month, but like minute limits. You can do only certain amount of calls in a minute. Daggerhand shared a script for that, which loads everything very quickly.
Oh, okay.
How to normalize your data? It's what I mean is discretizing it by along a sticker or along the server or along all the users.
Yes. So the features are generated based on the ticker,
Yeah.
and then I take a slice of it per day, and then I rank them, and then quantile. So it's quantile based on day, multiple features.
So it's by dates. It's not
Yeah.
by ticker.
Yes. So the feature generation is group by ticker, and the post processing is group by date.
Is there something that you do in the feature transformation, like, because you just did percentile rank, you said you just kind of want to make it look a bit like Numerai. Do you think there's whole other better ways to do that, maybe?
I haven't looked at it.
Okay.
That could be.
Have you played with those functions that are targeting and optimized correlation?
The like custom loss functions in
Yeah. I remember there was some discussion in the forum. They're talking about using the PyTorch autocorrelate function to optimize correlation, not do the mean square.
like Spearman correlation, differentiable as
Yeah, Spearman
I
correlation.
tried that a lot of time ago, but I'm currently using the Pearson's correlation. It can help.
In loss function.
But it's more about like feature generation and combining them rather than modeling.
Yeah, for sure. Data quality is more important.
We're actually thinking of working on maybe switching to a Pearson style correlation.
It should be lucky.
Yeah,
Oh,
on Numerai and signals, because, well, the reason we did the Spearman was just because like you guys could upload any shape distribution, and so okay, let's just do Spearman. But it turns out it's more predictive of TC if you do first normalize the prediction and then compute the Pearson correlation of that normalized prediction with returns or the target. So that's like a little bit more correlation with TC. So that's maybe a better version of core.
Does it actually makes a difference?
Yeah. It's also right. Like, you know, if you have very good Spearman correlation with returns, it isn't as good as having good Pearson in some way, right? Because returns are like a continuous thing.
Nice.
Okay. Thank you everyone. So
Yeah.
we are going for another break.